Some programs run forever. Others stop. Could a program look at any other program and tell which? The halting problem. Why no program can predict every program. Imagine an oracle. A program H that takes any program P and an input X and tells you whether P halts or loops forever. Turing's trick, suppose H exists. Build a new program, D. D takes a program P, calls H of P on P, and does the opposite of what H predicts. Now run D on itself. If D of D halts, H said halts, but then D should loop. If D of D loops, H said loops, but then D should halt. Either way, contradiction. So H cannot exist. No program can decide halting for every program. It's the bedrock of computability theory. Some questions about programs are fundamentally unanswerable by any program, on any computer ever. But specific cases work. Most real programs aren't adversarial. Type systems, termination checkers, static analyzers all settle. Just don't ask them to handle all inputs. Halting maps to Gödel's theorem. Some truths are unprovable. Some computations are unpredictable. The universe of programs has fundamental holes. We discovered them by asking too much of computation. Some limits aren't engineering limits, they're laws.